Rendering an element. Hey everyone, this is Ben Finkel, and in this nugget, we're going to take our initial steps into React, just get our toes wet, and learn about the very first thing that we want to do, which is rendering an element into HTML using the React DOM.render function. At this point, you should understand React.js is a library, a JavaScript library, and it's expressly for the purpose of creating your user interface, rendering your pages into HTML, CSS, and JavaScript. So, how exactly does it do this? Why is it such an interesting and cool tool to use? To understand that, I want to take a step back and I want to talk about web development in general a little bit, and something I call the holy trinity of web development. Now, the holy trinity I refer to is HTML, CSS, and JavaScript. I made that up. As far as I know, no one else uses it. You're welcome to use it, but if you do, you might get some strange looks because people won't know what you're talking about. But think about how web development or web applications ultimately work. You've got a user, right? And they key in address on their browser. They type it into their browser, or they click some links inside of their browser already, and that's basically sending up an HTTP request. Now that request goes out to whatever web server they are currently communicating with, and that web server can run a whole host of different software, .NET, Node, PHP, the list goes on and on and on. If it can code on a computer, it can probably handle HTTP requests. I'm sure somewhere out there someone's written a DOS batch file that acts as a web server to handle requests. If it can control the computer, it can probably handle and do some responsiveness for an HTTP request. But what does the server do with that request? Well, it does whatever the request asks it to do, but then it turns around and it produces HTML, CSS, and JavaScript. And the reason it does that, the reason I call these the holy trinity of web development, is because these are the only things that you can really count on your user being able to render to their screen. Their browser can take HTML, CSS, and JavaScript and turn it into whatever you want the user to see on the screen. But if you're developing for a web, you can only rely on those. It's not like you can send down Visual Basic code. Your user may be on an Android phone, or they could be on a Linux machine. They may not be able to interpret Visual Basic code. Browsers are going to spit back Visual Basic code anyways. They're not going to turn it into something the user can see on the screen. These are the only technologies that are recognized by your users. So everything you do as a web developer has to ultimately produce HTML, CSS, and JavaScript. And this is important for another reason. If you're used to developing local applications or applications that all exist inside of a single memory space, all of this is happening outside the memory space of the server. There is a really physical separation there between the HTML, CSS, and JavaScript and the server. Anything that these three, the Holy Trinity, doesn't have in it, it's going to have to go back and get from the server at some point if it needs it in order to render it to the screen. And this produces a really interesting problem with what we call state management, the state of the web page. And the state of the web page is, well, what the user has done to it. So it gets sent down, it gets delivered right here in an initial state. We'll call that the initial state of the web page. And then the user may do stuff. They may update some values on it, they may change some things. They may scroll down. Imagine on Twitter, if you use twitter.com, the infinity scroll. Infinity scroll is where you can just keep scrolling down, scrolling down, scrolling down over and over and over. It doesn't load every tweet that was ever tweeted in the history of the universe. It just, as you scroll down, it loads the next 10 or 15 tweets that you might need that you're going to scroll down into, and it keeps doing that over and over and over. But you've changed the state of the page. You have scrolled down through 30 tweets, right? And then let's say you do something. Let's say you click that little, well, now it's a heart. So you click that heart button, right? That's indicating to the server that, hey, you favorited this tweet. Now your page needs to update. It needs to do some back and forth communication with the server. If the whole page got updated from the server, well, you'd lose your state. You would zip all the way back up to the top. You'd have to scroll down again. That would be really annoying. We would be annoyed by that as a user. So users expect statefulness out of their applications, even their web applications now. They expect that the things that they have done to the page to stick through communication back and forth with the server, and it wasn't always the case that this happened. There used to be something called postbacks with web development, and a postback was where the entire page got delivered up to the server. The server did something with it, and then it delivered the entire page back. And if you wanted to maintain state during a postback, the entire state of the web page had to be sent up to the server. The server re-rendered it and then recreated it in that state it was in, and then sent it back down to you. And this was, if it sounds like kind of a nightmare to manage, well, it was. So enter web development technologies. In the past probably decade or so, we've really gotten a lot of cool and interesting solutions for this. And React.js is one of the newest and really one of the hottest. It does a really great job of dealing with this particular issue, particularly the issue of state. Now, just a side note before we continue on, I've already used, and you're going to hear me continue to use the word rendering or render a lot, both in this nugget and throughout this entire course. And when I talk about render, 9 out of 10 times what I'm talking about is I'm talking about producing the HTML, CSS, and JavaScript. I'm talking about combining data and code and rendering that into primarily HTML, but also CSS and JavaScript, because this is ultimately what your browser is going to use to draw on the screen. So rendering is producing that output. Rendering is also drawing on the screen. Your browser renders HTML to the screen. I'll use that sometimes as well, but typically I'll say render to the screen versus rendering to HTML. That's how you can tell exactly what I'm referring to. But generally speaking, when I'm talking about rendering from here on out, I'm talking about rendering to HTML, CSS, and JavaScript, because your browser is going to handle the rest. Your users' browsers will handle it from there. All you need to worry about is producing good, parsable HTML, CSS, and JavaScript. And there's two ways really that you can render in the world of web development: server-side rendering and client-side rendering, which are exactly what they sound like. In server-side rendering, you produce all of your holy trinity and send it down to the client to draw on the screen. In client-side rendering, you produce some of what you need to be drawn on the screen, but then some additional work has to get done on the client side. And React.js, initially the way we're going to describe it, is a client-side rendering package, although it can also be server-side. But what that should mean to you, if you render client side, what you should think is, hey, I still only got HTML, CSS, and JavaScript available to me, so all of my client side rendering, yes, has to be done in JavaScript. And that's why React.js and really any of these packages that you run into, Ember, Knockout, Angular, etc., that's why they're all JS libraries. They're JavaScript libraries because they can execute inside of the browser and do their work on the client side. Now, back to the original task at hand, the problem at hand. How do we create a nice responsive application where the state of the web page is remembered, but there's still communication happening with a server that's on an external server that's over the public internet and is completely disconnected memory-wise from where my page is operating? Well, the thing to understand about rendering the DOM, and the DOM is really just the Holy Trinity, particularly though the DOM is referring to the HTML. Rendering that DOM, rendering that HTML is kind of slow and inefficient and can be confusing, right? So it's a problem if we have to re-render the entire DOM every time something changes. If every button click, if every update requires a re-rendering of the DOM, our users are quickly going to get annoyed. If you used web pages back in the late 90s and early 2000s, you recall this. Every time you updated something, the whole page had to refresh, and sometimes it would take 2 or 3 or 4 or 5 seconds for it to come back to you. That was obnoxious. No one liked it. No one liked using web pages that way. Along came Ajax, and that started to get us into the world of today, where pages were a little more responsive and they updated in the background asynchronously while we were working with them. But maintaining state and managing state is still a really confusing, difficult topic for us as developers. What we'd really like to do is we'd like to simply re-render the DOM every single time. If I were a developer and I had my way, I would write my code such that I was rewriting the entire DOM every time something happened. I just didn't care about state management. I'd rather let somebody else worry about state management. And that's what React does for us. It cares about state management, and it does it through a really clever technique called the virtual DOM. So the way it works is you write your JavaScript, your React.js JavaScript, and that JavaScript goes through the React compiler, and the React compiler writes out a virtual DOM. And a virtual DOM is an in-memory DOM. Why do we do that? Well, a couple of different reasons. One, it's really fast to render. Because all of this is happening in memory, it all happens very, very quickly. In fact, the faster the user's computer, the quicker it's going to happen, right? If they have nice fast memory, it's going to be lightning fast. Even an old slow computer, though, stuff that's happening in RAM happens very, very quickly. The other thing that's really cool is we can have many different states of the DOM. Specifically, we have our current state and our next state. This is an important concept in React. So when a user updates something or changes something, React goes through this process and re-renders the virtual DOM, and now it's got two DOMs in memory. It's got the current state and the next state, the state that they've updated to. The reason it does that is because it doesn't have to rewrite the entire virtual DOM down into the real DOM. It performs a diff between those two DOMs. Maybe only one tiny little itty bitty thing has changed, and if that's the case, it creates a new real DOM, but it only updates that teeny little bit. It's very, very quick now because it doesn't have to re-render the entire DOM. It's only re-rendering that little bit that has changed. So it can very quickly perform an in-memory diff between our two different states, figure out what's changed, and send that down to the browser to get drawn on the screen. So React.js takes our JavaScript, turns it into a virtual DOM, diffs that virtual DOM against the previous iteration of the virtual DOM, updates the real DOM with whatever needs to change in order to bring the previous version current with the next version, and then that's what gets drawn to the screen. Great. I know what you might be thinking, and you're absolutely correct. Manipulating the DOM, writing out the DOM in JavaScript, which is what we are talking about doing right here, is not all that easy. It's actually kind of ugly and confusing and is weird. If you've ever used jQuery, you know that it can get a little bit hairy trying to manipulate the DOM through JavaScript. But here's where I think React is different. I think jQuery didn't go far enough. React said, you know what? We are going to do all of our DOM rendering inside of JavaScript. Forget about HTML entirely. JavaScript is now our DOM rendering language, which means you start and end in JavaScript and you don't even worry about the HTML. So in order for that to work, we got to have some really great JavaScript libraries available to us. And the first one that we're going to talk about here, the whole point of all of this nugget, is to talk about the render function, React DOM.render. I've got a little element or a little chart here of the variables that React DOM.render takes. That includes React element, which is the element to render to the screen. It's very important that this is a type React element. It's not just an element, but it's a very specific type from React. We have our DOM element, which is the target DOM element that we want to render into. And then optionally, we have a callback function, as you frequently do in JavaScript libraries. That's good to see. I've got some live code here up on JS Fiddle that we are going to use to see a little bit of this in action. Here's my first one. Feel free to check out this URL on your own. Again, play with it as much as you want. But all I've done here is I've got a very, very simple HTML page with a div called container. That is my mount point for my React.js. And down here I'm calling React DOM.render. I'm passing in my three variables. There is my element to render, there's my target DOM, and here is my callback function. So what am I rendering? Well, I'm rendering an H1 hello world. Makes sense. I'm rendering into document.getElementById container. That's my little div up here. And when I'm done, I'm calling my callback, and I'm just got a little window alert that calls out done. So let's go ahead and click run. We'll see it happen. Super easy, lickety split. There's done. There's my hello world in H1 tags. A couple of important notes here. It rendered this all inside of the div. When we get into rendering complex components and you're updating or refreshing these components, well, it's going to pull a diff and it's going to update only what it needs to update. But the initial time that it did it, right there when I clicked run, it overwrote anything that was in the div before. But it won't overwrite the div itself. So I can't change anything about the container, my target container that I'm putting my, my React element into. But I can and I will overwrite anything that's inside that container. Now, I mentioned this in an earlier nugget, but you should probably be scratching your head a little bit at this syntax right here, this H1 syntax, which frankly looks like HTML, but it's inside of my JavaScript. And this is to help alleviate that problem that I just mentioned with JavaScript being a little bit confusing for manipulating your DOM. One of the things that they've done is they've built a language called JSX, which stands for JavaScript XML, and it's a way to embed XML-looking syntax into our JavaScript very naturally and very easily, and that's what you're seeing right here. This code is actually going through a pre-render step, and that pre-render step is included up here in this little script that I had to include, and it's turning that JSX into valid JavaScript. I've got a second fiddle up here. It's the exact same thing, except I replaced the JSX with the JavaScript equivalent. Either of these can be used. They are both perfectly and accurately completely the same. The JSX that I just showed you, or this react.dom.h1 command. They're doing the exact same thing. In fact, that previous code was rendered into this code. The only reason that you would want to use the JSX, I believe, is readability. There's no reason not to use it. It's a big part of React, and it makes your JavaScript code, it's going to make your DOM manipulation JavaScript code that much easier to read. So I highly recommend you stick to the H1, but it is important to note that it's ultimately just turned into this kind of valid JavaScript before it's sent on to the React compiler. So get used to the React DOM.render function. We're going to be seeing it and using it quite a bit. It's a big linchpin piece of working with React. So that concludes this nugget on rendering an element with React.js. To recap a little bit, React.js is all about rendering to your DOM, your HTML, JavaScript, and CSS. And in order to do that, React uses something called the virtual DOM, and that means that we have to write all of our rendering code inside of JavaScript. Now that's going to end up being very, very complicated and very, very powerful for us, but we just took our initial steps now and looked at something called the React DOM.render function, which just allows us to render basic HTML through React into our virtual DOM and ultimately into our real DOM. I hope this has been informative for you, and I'd like to thank you for viewing.